Okay, so what is a ratio? And this video is also about proportions. So I want to get started with ratios. And what are ratios? Ratios are fractions. That's all they are. So if you have a fraction of 1 over 2, that's the same thing as saying you have a ratio of 1 to 2. So these two things, when I look at those, I really, in my mind, I don't see any difference between them. So you might hear something about in an election, um, one party beat the other party by a 3-to-1 ratio. Okay, so what that means is that the number 3 would be the top of the fraction. So 3, let's just say, what's a political party? How about the Green Party? And divided by 1 for some other party, let's say the Democrats. So this fraction is the same thing as that ratio. For every 3 Green Party votes, there was 1 Democrat vote. See how that works? So ratios and fractions, they're really no different. Sometimes the numbers aren't as nice and clean as 1 to 2 or 3 to 1. Sometimes the numbers are a little bit messy. Maybe you'll have something like in a classroom you might have 16 boys and you might have 13 girls. Okay, so what is that? That is a ratio, and it would be 16 over 13. So if our ratio of boys to girls was 16 boys to 13 girls, how would we simplify that? Well, what we could do is we could actually do this math problem. We could bring up our calculator here, and we could go 16 divided by 13, and we get a fraction 1.23 and a whole bunch of decimals. Let's just keep it at 1.2. So that means that this fraction or this ratio is the same thing as 1.2 to 1. So all three of these things are equivalent. In this one, what we did was we wrote it as a fraction, and in these two, we wrote it as a ratio. So what's the difference between these two? Nothing really. The only difference is that I simplified this down so that at least as one of my terms, I would have a 1. So 16 to 13, boys to girls, is the same thing as 1.2 to 1. So 1.2 boys for every girl. Okay, so that's the idea of a ratio. Okay, next, I want to talk about proportions. And so what is a proportion? A proportion is pretty easy. All it is a proportion is when two ratios equal each other. Okay, so let me try and keep the examples as easy as I can. So let's say 1 out of every 2 people has dark hair. So that would mean that 4 out of every 8 people has dark hair. So these two fractions equal each other. That means they are proportional. That's all. That's all proportional means. Two fractions equal each other. And what's the proof? I mean, 4 over 8 is reducible to 1 over 2, so yeah, they equal each other. So sometimes on the ACT, what you'll see is you'll see questions like this. You'll see and forgive me for keeping my numbers easy, but I'm going to do this. So they'll give you a couple of triangles, and they'll say, okay, this is 1, and that's 2, and that's 3. And they'll say, this is 2, this is 4, and this is 6. So they'll say, is this proportional? So what you're supposed to do is you're supposed to be able to look at this and see whether these two triangles are similar or not, whether they have similar proportions. So what you do is you just pick a couple of the sides, like let's say we pick the short side and let's say the long side, and you write them as a fraction. So you go, okay, we've got 1 over 2, and does that equal 3 over 6? If this is true, then yes, they are proportional. And since 3 over 6 reduces, divide both these by 3, you get 1 over 2. Yes, they are proportional. So let's do an example where they're not proportional. So let me think one of those up. I guess I'll leave this one the same, and I'll draw another triangle here. So let's draw a triangle. And let's say this is 5, and this is 3, and this is 6. Does that even work? Just a second. Okay. I guess I should make this be 5.8, so that way I don't get screamed at by anybody who follows me. Okay, so these two triangles, are they proportional or not? Well, okay, we've got the shortest side, we've got a little bit longer side, and then we've got the hypotenuse. So what we'll do is we will pick a couple of those, and since I already picked the shortest side and the hypotenuse, I'll do the same thing again. So here's that, and then here's this. So these are the sides I'm going to look at. And I'm going to go, okay, so I'm going to go 2 over, it doesn't really matter whether I pick the 6 or the 3. I'm going to go 2 over 3. Does that equal 6 over 5.8? If this is true, then they are proportional. If it's not true, then they are not proportional. So how can I test to see if they're proportional? I will do the cross multiplying trick. I will see if the two sides equal each other. So I will see if 6 times 3 equals 2 times 5.8. If that's true, then they're proportional. So 6 times 3, I can do that in my head. That's 18. And then 5.8 times 2, what's that? 6 times 2 is 12. So what's that? 11.6. So since these two do not equal each other, then these two triangles are not proportional. At this point, I'm kind of worried that I may have gone a little too fast. I mentioned a minute or two ago that it doesn't matter whether you pick to do the 2 over the 3 or the 2 over the 6. The reason why it doesn't matter is because as long as you do it the same on both sides, you're going to have a similar representation. So if I do, and in this example right here, I did the green over the green. I did the 2 short sides, and then I did the 2 hypotenuses. Or would that be hypotenae? I really don't know. But anyway, so I chose that way to do it. But what if I had chosen, instead of 2 over 3, what if I did green over orange? What if I did 2 over 6, and then I did green over orange, 3 over 5.8? What if I did this? What would I get if I did my, my check to see if they were equal? Well, I would have, let's keep my colors the same here. What I would have was I would have 6 times 3, that's 18. And then I would have 5.8 times 2, so what's that? That's 11.6. So once again, either way, you get the same thing. It doesn't matter. As long as you do it the same on both sides, it's a good test to see if it's proportional. So you can see right here that these things do not equal each other. So once again, this one was not proportional. So what we'll do next is, here are 3 problems, and each of these 3 problems, I want you to just figure out, are they proportional or not? And what we'll do then is we will pause the video for a little while, and then we'll go over our answers. Okay, so let's check these out and let's see if they are proportional or not. So we'll look at this one first, and we'll do the cross multiplying trick. We'll go that times that, and we'll go this times this, and we'll see what we get. we get 2 times 9, that's 18. And we get 3 times 6, that's 18. Since these two fractions equal each other, then yes, it is proportional. Okay? Okay, look at this one. These are written as ratios. And are they proportional or not? Well, just using the quick test, you know, just kind of a common sense thing. This is double that, and this is double that. So I'm thinking that the answer is yes, but that might not be satisfying to you. You might actually want to see it done. So let's do this. Let's write these both as fractions. Let's go 10 over 5 equals 40 over 20. If you wanted to, you could do the cross multiplying thing. You could go, you know, 40 times 5 and 10 times 20. But in this case, I think it makes more sense to just go, okay, 10 divided by 5, that's 2. 40 divided by 2, that's 2. 2 does equal 2, so yeah, our common sense answer was correct. And then for the last one, we'll do the same thing again. We'll go 4 times 18. Let's see, 18 times 2 is 36. 36 times 2 is what, 72? And then 20 times 3. 20 times 3 is 60. So they do not equal each other. So this one, no, they are not proportional to each other. All right, so what else? All right, so I think a good place to stop would be to finish with this problem right here. This is kind of an ACT-ish problem, and it's got these two triangles, and I'm going to tell you that triangle, what is it, ABC is proportional to triangle GHI. So since we know that they're proportional, this problem says find x. So teachers, you have a choice. Make the kids do it and turn it in, or you can let the video play now and we'll see the solution. So here we go. If these triangles are proportional, then we know that the ratios must be equal. So I can pick any two sides I want, like the longest sides and what else? The shortest sides. Well, let's look at this. 9 and x. So since these two triangles are proportional to each other, that's what that sign right there means, then if I write those two as fractions, I can write 9 over 15 or 15 over 9. It doesn't really matter. I'm going to go 9 over 15 equals, so I went green over yellow, so I'm going to go green over yellow. So all I have to do is solve this, and I find out what x is. So let's use the cross-multiplying trick here. 15 times x is going to equal 9 times 10. So 9 times 10 is 90, and 15x. Just divide both sides by 15. That cancels out the 15. 90 divided by 15 is 4. So there you go. That's an example of using proportional triangles to figure out the length of something. Thanks for watching.